I'm gonna try and make a little bit of a better video. First and foremost, this meter is reading the input voltage, which comes down here to this side of the board, and there's two separate inputs. They reference to the same ground, so that would be your sine and cosine input from the sensor itself. And then this meter is reading the output voltage. Now, this meter actually reads about 0.1 to 0.2 volts, or sorry, 0.01 to 0.02 volts above that meter. So this is within 0.02 to 0.03 volts of each other, input to output. I've got that quite accurate. It's about the best I can do with the resistors I have in stock. I think this will work. I want to go over the circuit a little bit. So basically, first and foremost, your gray here, I'm going to label all these wires, but the gray input here is a negative input, and then the orange, we could call that input number 2, and the white input number 1. And then over here, your blue, or purple, whichever one it is, that one is output number 1. And then this red here, that comes from right here, my middle finger's pointing at it, that one is output number 2. These two wires over on this side, the black and the red, they're 12 volt supply. I will write it down and I'll send it in the notes with this thing. 12.0 to 12.2 is optimal, but 12.4 volts input is maximum. I will also add a little more cap to the input of this too, because I realize you guys might be trying to power it with a Sevcon or something. So nonetheless, try here to get the meters both in the same spot. So as you take your input voltage down, both sides will drop at the same time, and it will read very accurate. The meters probably don't quite react. They're not even, oh, they are the same brand actually, these ones, but basically it should give you your perfect signal input to output, and the response time should be really fast. Now, speaking of response time, Luke was asking if it was fast. This ACPL C87, I believe that's the model number of it, it's rated for 100 kilohertz. So just looking at the data sheet, I'll bring that up on the computer in a second. One thing I did was this little capacitor. You can see there's a blank cap spot on both input sides. I actually had a 47 microfarad capacitor, as well as a 4.7 microfarad capacitor, and then this one little one here. Right now I've actually switched that one there and this one here to a 10 NF cap. That is actually just to shield out some noise. So if this thing has too much of a delay, which it shouldn't, we're talking like, I'd have to work the math on that, but it shouldn't have much delay. It shouldn't even be measurable, let's call it that. The 10 NF cap can be removed, but it'll be a little more susceptible to noise, and we were trying to keep noise out of the circuit. That's adjustable, and you can always add more cap too, but I wouldn't suggest going more than probably 10 NF, maybe 100 NF, but definitely not more than a 100 NF cap on the input. That's just to decouple some noise, more or less. It's actually on the signal itself, so it's not filtering anything else. I think I've covered everything I need to show. This is the actual schematic, and I'm trying to remember, I've tried to make a couple of these videos, and I just want to double check that. First off, we can scroll through the data sheet here. It's an ACPL 87, and somewhere here it says up to 100 kilohertz bandwidth. So we're not trying to run it that fast. I believe we're going to be like 500 to 1000 hertz max. I'm pretty sure that's what the sine cosine sensor measures in. I have to try and double check how that works, but I know it's not that high of a frequency. The last thing I want to double check, oh yeah, these big resistor pads. This is originally built as a pre-charge measuring board. Each side of this, like the ground, would actually tie to the negative of my 470 volt battery pack in my CRX. One side measures the input side, like the battery side of the pre-charge resistor, and the other side measures the output side of the pre-charge resistor to know when it's at about 96%, and that's where I have it set. And that sends the signal out to an Arduino, which is isolated. That way we don't have to worry about any high voltage reference to anything whatsoever. It isolates everything for life safety. And then from there, once the Arduino sees it at 96%, it actually just turns on the second contactor. So that's where I developed this board from. For that matter, like right now it's reading bang on. It's super close anyway. Basically, I think this will work for what you guys need. It should be no problem. And then if it does work, I'll redesign it and make it a little more robust, shrink the whole size. I can bring it down to about half the size it is, I believe, and then I'll ship you out some more. Anyways, I'll talk to you later.